Actually, I'm sharing my screen. Hope also you give me a sign that you can see my screen also, no? All right, great, excellent. So first of all, I'll start immediately with my presentation. First of all, I wish you had a cool vacation and a relaxing vacation from your side. For me, it was okay. So for me, it was a little bit hectic and tough since we were updating almost all the books from KG till grade 12. As you know now, we moved from right-click to 01 with the updated version. Today till Thursday, we are going to animate sessions in order to refresh the memory for previous skills that we were together, and especially to introduce new techniques and new skills in terms of hardware that we are going to be using this year in our curriculum. I know that teachers that are in this meeting are divided into two categories. There is a category that they are using our curriculum right-click or 01, and there are teachers who are potentially interested in what we are giving. So, of course, you have my phone number. Please, I do ask you, if you have any question, any recommendation, any request, do send me this to my email or to my phone number. So I will start directly without any introduction to introduce the 01, sorry, the mBot2 robot, which you will be using this year, since you know all that you still see my screen, no? Okay, great. So okay, excellent. So you know very well that the robot EV3 from Lego is discontinued, and we were obliged to move directly to another educational robot in order to give this skills, those skills and this experience to our students. What you are going to see here in the PDF file is the content of the technical catalog in order to build the mBot2 robot that I have in hand. Initially, once you will be receiving your mBot, it will be in a box like this. And in this box, you will see that you have the aluminum chassis, you will have the motherboard, which includes a lithium battery, and the CyberPi that we will be explaining later on. So this is the first part of the box, which include the three main parts. Then in the box also we will be discovering this manual that you are exploring on the screen, and the line follower map in order to work on later. And of course you have two bags that includes the screwdriver, the cables, the motors, the sensors, the wheels, and other stuff. So what I'm exploring in the PDF right now in front of you is what you have inside the box. Once you know the hardware, we will be moving to the software in order to have a safe hands-on on the hardware and on the software. So in the box, you can see that you have the CyberPi, which is the microcontroller of the robot. You have the mBot shield. You have the ultrasonic sensor, the quad-core RGB sensor, 2 encoder motors, the chassis, aluminum chassis, the USB cable, the wheel hub, the slick tire, the mini wheel, and of course, you will have the cables, the screw, and especially the screwdriver that you can switch in both sides in order to work on. On the mBot shield, you have to know that it is an Arduino-based robot that you can attach any servo motor or any DC motor in order to extend the experience of your teaching skills. This was not available in the EV3 and in the other robots like the Vex and the Lego. On the shield of the mBot2, you have input for S1, S2, S3, and S4. And this means that you can attach 4 servo motors, which is incredible and amazing for extra activities. You have two M1 and M2 that is dedicated for DC motor, and you have what we call the EM1 and EM2, which are the encoder motors of the robot that comes with. I mean, those 2 motors down are called the encoder motor 1 and encoder motor 2, EM1 and EM2. And if you can see from behind, those 2 motors are attached to the motor down. So you have 2 free M1, M2, and you have from both sides S1, S2, S3, S4 in order to connect extra motors. This is very important for you to know in order not to be confused between what does it mean S1, S2, SM or EM1 and EM2. So this is regarding the mBot shield. Of course, on the mBot shield, you have built-in the lithium battery, and it is the first robot where you can detach the CyberPi that we will be talking later on to extend the option of programming and the skills that you might be doing. So I will move to the second page or third page, where we can explore the CyberPi by itself. And this CyberPi, you have to know, it's a powerful microcontroller that includes many input and output devices that were not available for the other robots. And in this CyberPi, you can have the light sensor, you can have, or you have already, a microphone, a full color display screen, the mBuild port, where you can attach an external device to add sensors for the CyberPi. You have button A, you have the home button, you have the USB port, you have a joystick, you have RGB LED strip, you have a gyroscope accelerometer sensor, the button B, it's built in with Wi-Fi and Bluetooth, extension port board, and of course, speaker. So imagine this small piece, you can have all what you need in order to build automation and if you want later on STEAM projects. You have to know that once you buy the box, or once you have this box, built in or inside it, you have the CyberPi. But if you want to buy additional CyberPis, because you can create extra missions with the CyberPi without the need of the just to make sure that I'm recording. All right. Without the need of the robot, you can buy as many as you want from the CyberPi, and we will exploring later on the different activities that we can make with this CyberPi. The ultrasonic sensor that is used in this robot, it's generation number 2, where you have a LED light in front of the ultrasonic sensor, where you can illuminate lights in order to give emotions and to give interaction with the students. The color sensor, which is unique, where 4 color sensors are built in. You have color sensor number 1, number 2, number 3, and number 4. And those 4 color sensor will guarantee the precision and the speed of recognition of the colors that are much, much more developed from the other robots. You can watch the video on YouTube, how fast the mBot2 is on the line follower. The screwdriver, it's very important to know, because me, as a first contact with the screwdriver, since I did not follow 100% exactly the catalog, I was a little bit frustrated somewhere, because the screwdriver, you can remove it and you can use it from both sides. And you have to know that for the screws, you have 2 types of screws, as you can see here. So you have to use the adequate side of the screwdriver in order to build correctly the robot. Here you can see that by following step by step, and this catalog, following step by step the instructions, will lead you to have the robot built without any errors. So it's clear. You can zoom in. I will be sharing it with you on our digital platform 01 in order to have it and to show it to your student in case you want to work together. So you will be watching step by step the different figures and pictures in order to create the robot. And once done, you will be moving to the software in order. All right. So you will be moving to the software in order to start making this experience interesting for your student. Just to make sure that everything is correct. All right, thank you. You are 64 person joining. Amazing. I really appreciate your trust. So I will be sorry. Okay. All right. So regarding the software, it's very important to know that the software exists in 2 versions. You can explore it. Just 1 second, please. I'm a little bit. Okay. Now you can see, I guess, my screen. So the program or the software that you will be using to explore the mBot2 is called the mBlock. But unfortunately, if you surf on the internet, you can see that there is many version of this software for the previous version of the mBlock, mBot or other products from MakeBlock. That's why it's very important to make sure that the software that you are using is the version 5.4. If you will use a version previous to 5.4, the robot will not function correctly. And you can search for it on the internet, or you can get it from our digital platform 01. This is first. Second, you have to know that through this application, it's very easy to see that you can create mission using the blocks or Python at the same time. So it's both platform by blocks or by Python. When you see the interface, you can check that it's like Scratch, but it is like Scratch. But of course, there is, let's say, another, some just 1 second. Oh my God. Okay. So there is a specific characteristics for this software. Once you launch it, you will see that you have on the left bottom 3 tabs, which are the devices, the sprites, and the background. In Scratch, we have only sprites and background. The devices, by default, you can explore that you have the CyberPi built in with the software. In case you click on the delete button without paying attention, all you have to do is click on the ad. And once you click on the ad, you will see that you have many devices that you can add on this software. You can add the Kodiroki, you can add the mBot range, the old mBot, you can add Raspberry Pi, you can add the microbit, the Arduino. Every hardware listed on this screen could be added, but we will not complicate things. We have to concentrate on the mBot2. Before adding again the CyberPi, sometimes if you have a new box to open and to start with, you might have you might need to update the driver of the CyberPi. That's why you will be seeing a blue arrow down, which is the download or the update next to the CyberPi. So you are in demand, or you are asked to update this CyberPi. So I click on the CyberPi, it's added. And from the category blocks, it's very important to know that you have like 6 or 7 category blocks related only for the CyberPi. It's very important to be aware of this. So by exploring those categories, you will see that you have the audio, you have the LED category, the display category, the motion sensing category, the sensing category, the LAN, the AI, and the IoT. To be honest, the last 3 are a bit advanced for the time being. We will be exploring them during the year once we finish our research based on those categories. So we will be concentrating for the moment on the category of audio, LED, display, motion sensing, and sensing. So if we click on the sprite, you will see that all those categories related to the CyberPi will be hidden. This is to tell you that it's very important to make students understand this feature, which is the CyberPy with all the categories that you have. And for the rest of the blocks, you will see that you have the events, the control, operators, variables, and my blocks. That I believe you know them and you are familiar with since you are working with Scratch. But till now, we cannot see where are the categories of the robot mBot2. This is why I have to click on the, and here you have to pay attention again. We have to click on the extensions, all right? And from the page opened, you will see that you have the Pocket Shield, the mBot2 Shield, the Ultrasonic 2 Shield, the Quad Core, Science Sensor, Smart Camera, and so on and so on. There is a huge list of accessories that you can have later on as extra hardware in order to extend this experience with the mBot2. And this is to show you how important is this feature or this robot. So look at this green downloadable button, which is the extension update. So every time, and this is very important, every time you see that you have a green arrow to update the mBot Shield or the ultrasonic sensor or the quad RGB sensor, you have to do it. You have to do it because the program might not work correctly. So once I click on the mBot Shield, you will notice that you have two categories added and not one. And this is a little bit critical for this operation. I will be explaining it right now. I click again on the extension. I click to add the ultrasonic 2, and then I click to add the quad RGB sensor. So till now, my software is ready to be used with 4 extra categories of blocks. So the most frustrating categories are, what is the difference between the mBot chassis and the mBot extension? As I told you before at the beginning of this session, this is the chassis and this is the extension. Okay, so every motor connected to the chassis will be controlled by the category mBot chassis. And here I mean only the two mBot encoder motors, EM1 and EM2. So if we will explore this category, we will see that if I click on, let's say, encoder motor, this block, I will open, I will see only encoder motor 1. We have to get used to the nomination, and encoder motor 2. And if we select, of course, all, it means that both motors will move forward at a rotation of 50 rounds per minute. I cannot tell you the speed of this robot that can arrive to 220. It is a super fast robot, very precise, very interactive with the sensors and the motors that they have. So all the blocks of this category are dedicated only for the encoder motor 1 and the encoder motor 2, just for this. By moving to the mBot extension, Here it's a little bit different. We will see that we have a variety of motors that we can add. So if we go for the second motor, and open the start, we should be you have more from now it's better. Okay, great, good. Okay, excellent. Thank you. Okay, thank you. So I was saying that in the mBot extension, okay, you have what we call the different motors that we can add to the extension, which are the servo motors, the 4 servo motors. You can have the motor 1 or motor 2, okay, and of course you can add what we call the LED strip light up, that it is an extension. If we go, so here I believe that you are aware of Okay, so it's clear now. So I believe here you are aware about the difference between the mBot chassis and the mBot extension. Believe me, if this notion is not clear enough for you, it will be a headache for you and for your students, because you will be always lost and you will be always confused about uh, from where you have to uh, from where you have to program the robot in order to move or to make any action. If I go through the ultrasonic sensor, you will see that there is a minimum number of blocks in order to control the ultrasonic sensor. And for the quad color sensor, it's the same also. You have the to control the the color sensor. And here it's very important to understand the logic of this color sensor, which are explained in the book. That if you open the probe, they mean by the probe, I will open my camera to show you. The probes are the 4 color sensors that are 1, 2, 3, and 4. The numbers are written on the color sensor. And here, why you have 4? To make the robot more precise and more accurate and more speedy in terms of recognizing the colors. That's why you have two color sensors on the right and 2 color sensors on the left, and they are coded by R2 right 2, R1 right 1, left 1, and left 2. And this color sensor is made by default to recognize line, a background color, the white, the red, the green, the blue, yellow, cyan, purple, and black, which will facilitate the task for the students in order to interact with this color sensor. I forget to tell you that this robot, in terms of encoder motor, is the unique motor where you can set your script to move the robot a specific distance and to turn a certain angle without making a calculation which is a little bit or too much difficult for lower grades to manipulate it. I believe you know that for those who received the book, that starting from grade 2, we integrated a robotics chapter with basic manipulation in order to enhance the robotic skills for students to arrive for a higher grades later on for the high in terms of difficult tasks and other stuff. That's why if you can see with me that with this robot, you can select the block move forward and you can set the distance in centimeter and in inch. Before, it was impossible. With the EV3 robot, there were this option was not available, and you were obliged to make the calculation of the perimeter and the pi, and there was a critical, let's say, math operation that we were obliged to do in order to make this calculation. Here, you can ask the robot to move forward 100 centimeters, then to turn left or right with a specific angle. This will make the task for kids in lower grades very simple and very task. Okay, I will ask you, please, I want to close all the cameras. Can you close the cameras, please? They are open. I'm searching from where I can enable start video. No, it's not from here. I can't find the option to turn off all the cameras. Excuse me, it has been a long time. I did not work with lock. No, it's okay. Please, can you turn off your cameras لو سمحتوا؟ لو فينا نطفي الكاميراز لو سمحتوا على كل حال. It's okay. So here it's really simple for them to it's very simple for them to manipulate this option in terms of centimeters and in terms of degrees. And for that, you can see that we have integrated a maze in the lessons, so students will enjoy making the robot move inside a maze in order to reach a target and so on. So this is how the software is made. You have to make sure that once you decide to save a mission, there is what we call the function or the command save as, which will take you to the cloud. And here, I believe that you are not obliged to go to the cloud in order to save your programs. And you have another command, which is save to your computer. So make sure always to ask your students to choose the option save to your computer locally offline. Now I move to the third part, which is how to connect the software to the hardware. And here it's very critical and it's very important to know the manipulation. I will just be preparing my desk a little bit. So I will show you that, sorry. Participant settings. No. Okay. Just because I lost my connect. Okay. No. I'm working on a Mac and I don't have enough USB, so I did. All right. So okay. So I have to share another family screen. Yes. All right. So with me, I have what we call the dongle for the robot. Okay, it does not come in the box. You have to get it alone. You have to buy it alone. It's not at all expensive, like $15 plus minus maybe. But this is a great advantage to use with the students. I will explain you and I will show you why. With this robot, okay, you can see that on the software, you have the connect button and you have what we call the live button and the upload button. And here, the difference between the upload and the live is very important to know. Once you get the box, you will have a USB cable with it. So every time you want to try a mission from a computer of your students, you have to connect the robot by cable to download the program and then to search for it in order to try it. It will take time, and from time to time, by plugging and unplugging the cable in the robot, you might have some defection in the port. That's why with this dongle Bluetooth, it's very important to use it. It will simplify you the task. It will be quick. No need to connect with wire. And all you have to do, please follow me by those steps that I'll be doing. All you have to do is to plug the I will try to show you. So I plugged my dongle. Okay, then I will turn on my robot. It will take like few seconds. It's on. Okay, I will click on connect. Automatically, it will detect the USB port. It's the Bluetooth port. I will click on connect. As you can see, it's connected. No wiring, it's wireless. Okay. If I go to the event category, I can move my block, the green flag. And since I am in the live mode, I will show you the moment I click on the green flag, the robot will move and it will not stop. Oh, sorry. Just 1 second. Okay, so the robot will move and will not stop because the mission is not correct. But as you saw that by clicking on the green flag, the mission will start. And what I'm trying to tell you, that in terms of management of the class, since you are in the classroom for 40 to 50 minutes, the minute is very important for you. That's why the use of this dongle is very important. Why? Because you have to minimize the time by not wiring the robot. So once you arrive on the robot, on the computer of your students, what you will be doing, you will be plugging the USB, click on connect, go to live mode, and try the mission. It will take you like seconds for 1 minute max. Once done, you will take this dongle, you will put it on another computer, and you will try it. And that's why it will be very fast to explore. I will go back a little bit to, so I think, or I believe that it's clear how to manage the connectivity. So as a recap, first I show you, and I'll be uploading on the platform, the manual of the robot in order to build the robot. Second, I showed you the software, mBot2, and it should be a 4.5 version. I showed you that this software has a specific characteristics which is that you have a tab called the device where the CyberPi is built in on the system. Then after the extension to add the mBot chassis, mBot extension with the ultrasonic and the quad core, I showed you the difference between the controlling the encoder motor from the mBot chassis category and the servo motor and the motors, DC motors from the mBot extension, and the characteristics of the ultrasonic sensor and the quad core sensor with the 4 quad core, right 1, right 2, left 1, left 2. And finally, I showed you a bit how to connect with using the dongle and how to go in live mode, and when you have to update your CyberPi or any kind of sensors the moment you have the green flag in order to download. This was a recap of what we've did today, and I believe that this introduction will help you a lot in order to handle in a safe way this robot. I will go back to the CyberPi category, which is very important for you and for the students. In the audio category, the most important blocks are the start recording and the stop recording and the play recording. They are, let's say, new for the robotics world, where this robot includes a microphone and a speaker, and you can create interactivity with your robots. It's very important for you to master. Of course, you have what we call the increase, the decrease, the play notes. So I believe those are not difficult for you. The LED category are to control the 5 RGB LEDs that are here. So if let's say I'm connected now, I don't know if it will work. Just 1 second. I've turned off the robot. So I connect again. And once I click on the green flag, you will see that the colors are active. Okay, so here the importance of those LEDs is students can control, and this is an algorithmic mission. Students can control each single LED. It's not like, just like a LED to show off or to show on. No, it's really different because you can create multiple scenarios with it. With the display, and here we have another important block, you have the display on the screen. It's a full LCD screen where you can create display static information, or you can display what we call you can display variables or reading sensors or generate graph and other stuff. The difference between the motion sensing and the sensing are really clear. The motion sensing, all the sensors that are included in the CyberPi, which are the tilt, the wave, the shaking, the motion sensor, the angle speed, and the rotation. By the sensing, the normal sensing, not related to motion, you can check the joystick that I showed you, that I have a joystick that I can control my robot with the joystick or the buttons that are considered as let's say sensors or push buttons. You can have the you have a loudness sensor that you can detect a sound for creating emission to control the security of a room, for example. the ambient light intensity. On the CyberPi here, you have a light intensity. If you hide it, it's like a dark. If you show it, it's like day. You have the timer. It's another another sensing, and of course the battery level to show you if you have enough battery in order to charge. What I missed to tell you that for this robot, you don't need an external charger like in the EV3. All you have to do is to plug it on your computer on a USB, and the battery will charge super fast. Okay? So, and of course, the blocks events and control and operation, I believe you know them very well. What is new in the software is that you can create a mixture of mission between the CyberPi and the Panda. And as you can see in the motion sensing control, look here, you have a block called control the Panda to follow the CyberPi with sensitivity, and you can precise the sensitivity level. So imagine here the creativity that you can ask for your students in order to show them how they will explore this combination of the software and the hardware at the same time. Again, this is new for the robotics world. It was not available in the other robots before. So I believe that for this first session, I did cover most of the let's say main parts in order to be safe, to explore in a clear way what you are going to explore in our curriculum. You have to know that I will be sharing with you just 1 second. Great. Quickly, in few minutes, not to make you to respect, if you want the. So here, I believe you can see. Okay. This is the chapter. You can see my. Please, can you stop writing on the. And. All right. Okay. Share. Okay. Can you see now my my file, my PDF file? Okay, great. Okay, so here I want to show you in a quick way, like we have like 5 minutes, not more. I will not. I know that you were at school today and it's a little bit hectic. So I'll be telling you that I'll be sharing with you a PowerPoint in order to tell you, to guide you, to help you how to start with the robotics in terms of introduction to students. And please do apply this introduction for all the levels, because in robotics, you have to know that we have to develop skills at 3 levels. The first level is the general culture, the general know-how. I mean, no sense for what you are doing with your students if a parent or a teacher will ask your students, for example, give me the definition of a sensor, or for example, where we can find robots. So general questions regarding the science of robotics, if your students are not able to answer to, believe me, no need for all the efforts that you will be doing later. So it's very important for you as teacher to focus and to concentrate on what we call the introduction or the know-how of the robotics world in terms of general knowledge. and your students must have this knowledge. And during the assessment that you will be doing, you have to ask them questions that turns around what we call the general knowledge and the general culture. Second level of development skills in robotics, it's the software, how to create missions, okay, how to deal with the robot in terms of the robot by itself. And in a third step, or in a third stage, you can explore with your students by using extra kits like the mBot smart word add-on pack, where students will explore additional kits that they can build, like this mechanical arm, where this arm will be attached to the robot in order to perform or to create specific mission, in order to catch a bottle or any object, and so on. And as you can see in the robot, since it is an Arduino based, and from all sides of the shield there is holes. This is to tell you, and even from here up there is holes. This is to tell you that later on, if you want to extend this robot in terms of hardware, you can do it. You can attach additional items, additional hardware, in order to create features and extra features for this. I want to tell you also, before ending the session, I'd like to thank you very much. You stayed till the end. That for this robot mBot2, there is an international competition that we will start handling it in Saudi Arabia for this year. It's called the Make X. I will write it on the Make X. Okay, this is an international competition where students will be using the mBot2 in order to participate to international competition. And we are the local organizer in Lebanon. So we have the needed experience to give it to you in order to help you participate in this competition in case you want. So I'll be ending today this session by let's say showing you how clear, how simple, how guided are the lessons in our curriculum. And for those who are using our platform, they can get access to the lesson plan or the teacher guide in terms of reading and exploring every single steps that you will be performing for each lesson. So the first lesson, here we are talking about the grade 2. So here we'll be exploring the definition of the robot, who invented the robot, where robots are found, what task can a robot perform. We ask students to draw some cartoon robot and then go to the paint program in order to create a hand-on robots. And at the end of the lesson, to watch a video. Lesson 2, we will have a recap on what we call the what we've learned in the previous lesson. Who invented the robot, where the robot are found, what tasks can be the robot perform, the different kinds of robots, educational robot, to make students understand that there is different shape and different brands of robot. We'll explore the mBot2 like the one they have and how it is built, and the difference between the motor and the wheel. And in lesson 3, we will explore the different items of the robot. What are the missions that we can do? And we make a parallelism or a comparison between the Scratch Junior program and the mBot program in order to make students understand that in Scratch Junior, we program the sprite to perform a mission. In the mBot, we are going to perform, to control or to create a mission to control the robot. And in lesson 4, we will start directly with the mBot, showing them how to add the robot mBot shield, to examine the category, and to start building a simple mission. In grade 5, in lesson 5, you will be controlling the robot by moving forward, backward, turning left, right. You will be asked to draw a maze on the table or on the floor, and to ask students to create this mission and to control the LEDs. And from now, all the lessons are challenges, are missions, are competitions in order to explore and to enhance this curiosity for the students to explore those missions. You will see that from a lesson to another, the missions will be harder and the missions will be complicated by adding additional features like the sound recognition, the push button of the joysticks, and so on. I will stop here. I stop sharing. So I'll stop here, and hopefully I did transmit to you what you are in need for in order to start exploring this robotic chapter. I know very well that in our curriculum 01, it's not included as first chapter. So you have the time to get the robot and to practice on. I'll be showing you later on extra missions and extra videos regarding this. For those who are using the right-click curriculum, not the 01, you can contact me directly in order to send you privately as a PDF in order to explore it as a chapter. Please, on this chat, do not ask me to add books on the platform. Please send me a WhatsApp or an email, because here I'll be lost somewhere in your request. If you have a specific request, you can send it by chat. I'll be reading it later on. I'd like to thank you very much. Tomorrow, at the same time, I'll be sending you a reminder. Tomorrow, we have an amazing presentation for Arduino. And I did Arduino before with you, I guess. But this time, we will be exploring Arduino starting grade 7. So before it was like from grade 10. Now we will be exploring grade 7 Arduino in order to move forward, to explore more the world of STEAM, of IoT, artificial intelligence, and many more. Actually, I did not have, if you give me just 1 second, to share with you the Google form in order to fill it, just to send you later on the just give me 1 second, please, to send you the certification of participation. Just 1 second, please. Do not leave. Okay. I will send it to you in few seconds. All right. I will remove All right. So I'll be sharing with you copy on the chat. Where is my chat? Yalla, just 1 second, sorry. Where is the chat? Okay. So the Google form is sent. Please, can you fill it? Please, can you fill it in order to send you later on the certificate of participation? So once you fill the form, so I believe you received the Google form. Please do fill it. I'll be working on sending you the certificate of participation. And please do not forget, tomorrow we will be having Arduino. After tomorrow, we will be having an exciting also Zoom. No, you have to fill this for the participation, because I want to make sure that you have participated in order to give you the certificate, because you might register for being present and you are not able to join, so you will not get the certification. So only the 74 people that are here can fill the form to have the certificate. So I was saying that on Wednesday, we will be exploring the microbit with the STEAM product, which are the greenhouse, air quality station, traffic light, and other stuff. I'd like to thank you very much.